Hello, everyone. Welcome back to chemistry. We're sort of picking up right where everyone left off. So most likely you left off the year right around chapter 14, all the gas laws. So we're picking up unit 8 on solutions and starting with chapter 15, water and aqueous systems. And a lot of this is review. So there isn't actually too much notes in 15.1. It's just a review of what we already know about water. And really the most important thing that you need to know about water is that it is very polar, one of the most polar molecules that we come in contact with. And so, you may be asked to explain why a particular molecule is polar. When you always talk about when we talk about why a molecule is polar, we would want to say something about the electron density is not symmetrical, because oxygen is a very electronegative atom and hydrogen is a very small and just has sort of a medium electronegativity. The oxygen side of the atom is where the electrons spend most of their time. Therefore, that side of the molecule is partially, remember the symbol, lowercase delta, means partially negative. We actually have a way to quantify how polar a molecule is. You may or may not in physics at one point learn about vectors. You may have learned about it in math class. Basically, it has to do with adding vectors, and you get an actual measurement of water. You can see there water is fairly polar. Because water is so polar, and because it is an oxygen bonded to a hydrogen, it can form very strong intermolecular forces. And remember, the strongest intermolecular force that we have are called hydrogen bonds, which are not bonds. In order to have a hydrogen bond, you need to have a hydrogen bonded to the three most electronegative elements, right? A hydrogen bonded to a fluorine or oxygen or nitrogen. That will make that molecule able to hydrogen bond. It can hydrogen bond, or that hydrogen will be the partially negative part. These guys will be the partially positive part. Ooh, that's wrong. How about I say that correctly? The hydrogen is the partially positive part, and the fluorine, oxygen, or nitrogen is the partially negative part. And that can be attracted to any other oxygen, nitrogen, or fluorine on another molecule. Most of the time we talk about hydrogen bonding within molecules of the same substance. So the picture down here shows us the one unique property that happens with water, and that is that solid water, ice, right, is actually less dense than liquid water, right? And the reason for that is because ice is solid, it is a crystalline solid. And we know that crystalline solids have to set up in a regular repeating pattern. And this regular repeating pattern of 6 water molecules lined up like this causes the space in between the water molecules to be quite large. And that's why actually liquid water, when the molecules don't have to be in any sort of pattern, they can be arranged in any way to get as close to each other as possible, to attract each other as possible, you can actually get the molecules closer. So that's just kind of a fun, that's the end of it. So that's just a fun fact about water, basically. So we're going to use everything we know about water and start talking about it in terms of the solutions that it makes.